Okay, so now let's look at question number 12, part A of the applied paper. So this is the relative acceleration question. So they have given us a diagram. So there's wedge x, wedge y, and this particle p shown in the figure. AC, DE, EF are AC is what? AC, DE, and EF. Those are lines of greater slopes of the faces containing them with this angle alpha. DEF is beta, and very important, beta is less than alpha. So remember that. Then the face containing AB of the wedge X of mass m1. Right. So this one has mass m1 is placed on a smooth horizontal table. So we don't need to worry about friction here. Right. The face containing EF of wedge Y of mass m2. Right. So this one is m2. Y is m2 is placed on face containing AC. All of these surfaces are smooth because why? Smooth uniform wedges. So these surfaces are smooth. So there's no friction. Right. Containing AC and the particle P of mass m. Right. This one is m. Simple m. Is placed on DE. System is released from rest. Write down the equation sufficient to determine the acceleration of wedge X. Right. While the wedge Y moves with face containing EF, touching face AC, and particle P touching D. Right. Okay. So for this one, draw a big diagram because we need to figure out the angles correctly. So draw a diagram that will you can easily see the angles correctly. So this one, right. Yes, our wedge X, A, B, C. Right. Then right, we'll mark this. This is angle alpha. Then we'll draw wedge Y, and this angle is given to be beta. So right, beta is less than alpha. Right. And there's what? Particle P, which is right. This one is X, this one is Y, this one is particle P. Right. Okay, everything is marked. Right. Then we want to find the what? Sufficient equations to determine the acceleration of wedge X. So then it is clear now, wedge X is going to move in that direction, because if you mark the forces for the wedge X, what are the forces acting on wedge X? Its mass, so weight m1 g, then this reaction r1, those are vertical, but there's what else? There's a reaction from the wedge y, no? That is, let's say r2. So there's a reaction again in this direction for the wedge y, r2. Right. So then there's, this is the weight of the wedge y, so that is m2g. Right. And we'll mark forces for p also. Weight of p is what? mg, and what else works on p? the reaction is perpendicular to the surface, so that is r3, and there's r3 in that direction, right? So all the forces are marked. Now only look at the forces on wedge x. So what are the forces on wedge x? Weight m1g, reaction r1, and this reaction r2. Because of this reaction, its horizontal component is in this direction. That is why the wedge x is moving in that direction. So let's say the wedge x acceleration is capital F, right? So that is clear. Then wedge y is obviously going down the slope because of this m2g, the weight, right? So that will go in this direction. So let's mark that acceleration as Fy. And then the particle acceleration also we need to consider. That is going along this what is this dE uh, surface. It's going along that surface dE. So that is F of P or Fp. So that acceleration is Fp, right? Maybe let's mark the acceleration with a different color to make it clear. F Fp Fy, right? Okay, so everything is now marked, the accelerations and the forces, right? Okay, some angles also we have to figure out. This is alpha, this is alpha, this is 90, then this is 90 minus alpha, this angle, then this angle has to be alpha, right? So this is alpha. Then another angle we need is this one. So let me draw a horizontal line like that. Then if this is alpha, this big angle is what? That is alpha, the Z-shape angles. Then the small angle is what? That small angle is alpha minus beta, right? That is something we need, right? And what else? Right, this is 90 degrees, this is 90 degrees, this is 90, this is 90 degrees, right? Okay, okay, we need this angle also. So what do we know? This is, how do we find that one? We know alpha minus beta, beta, right? This is beta, right? So right, okay. We'll come back to this angle, right? So let's define the terms. Acceleration of wedge x relative to earth, we know that is F, capital F, that we need to find. So a x e capital F. Then what else? This one Fy, this is relative to wedge x, so that is a yx. So that is going what, in this direction. Fy, this angle is alpha, so this is same as what? This is same as this Fy, and this angle is alpha, right? Then we also have this one, fp is uh, acceleration of the particle relative to wedge y. So apy, that is in what, that is this one, and this angle is what, that is why we needed to find this angle alpha minus beta. So this is alpha minus beta, and this is f of p, fp, right? So now we want to find enough equations to figure out capital F. So how many unknowns here? Capital F, Fy, and Fp, three unknowns. So we need to write down three equations. That is sufficient to find capital F. So we just need to write three equations. One for, okay, so let's do, we are going to use F equals ma. No? So F equals ma, we have to apply relative to Earth. So we have to figure out acceleration of wedge y relative to Earth and acceleration of particle relative to Earth. So acceleration of wedge y relative to Earth is going to be what? A yx plus a xe. So that is this plus this, right? So we'll figure out those later on when we need them. Right. We also need acceleration of particle p relative to Earth. So that is what? That involves three components: a py, a yx plus a xe. So a py is alpha minus beta, fp, a yx, alpha is bigger than alpha minus beta, remember, that is important. So that is fy plus a xe is in that direction, capital F, right? Okay, so the important accelerations are these ones relative to Earth. So these expressions will come back to these three expressions when we apply F equals ma, right? Okay, so what we'll do is we'll first apply F equals ma to the system. Then we don't need to consider what, R3, R3, R2, R2. Those are all going to cancel out reactions. We are going to apply it in the direction where the wedge is moving. Wedge x is moving to the right. So we'll do system. We're going to apply F equals ma to the system in this direction. So no need to worry about R3 or R2, they cancel. mg, m2g, m1g are all vertical, so no need to worry. So R1 is also vertical, so there's no forces in the forces side. So F equals ma, force side is 0. Then each mass, you look at each mass and their acceleration. So wedge x is m1 mass, acceleration is f in that direction, so positive m1 f, right? Then wedge y, that is mass m2, so plus m2, what is its acceleration? M2 acceleration, so wedge y acceleration is plus f. Then fp component in that direction, so that is going to be what, fp cos alpha in the negative direction. So you have then f minus fp cos alpha, right? So that is m2 Then particle p mass is simple m. So simple m, what is the acceleration? So acceleration is, from using this we can figure out capital F is in positive direction. So F positive. So F, other two are negative. They are, we want the component in horizontal direction. So this one is Fy cos alpha negative, and this one is Fp cos alpha minus beta negative. Right. Right. Minus Fy cos alpha minus Fp cos alpha minus beta. Right. So this is our first equation, and we need to now, don't need to simplify or anything like that, just leave it like this. So this is one equation. We need to create two more equations because we have three unknowns, capital F, Fy and Fp. Right. So the next equation, how do we create? We will create it. Now we did the system. Now we can look at what? Wedge y and the particle p together. Why are we taking them together? What is the reason for taking y and p together? Reason is then I don't need to worry about what? R3. Yeah, R3 will cancel out. So that is why I'm taking wedge and p together, and I'm going to apply it in the direction F equals ma, in the direction where wedge y is traveling. So we are going to apply to particle p and wedge y together, and we are going to apply it in this direction, in the direction where wedge y is traveling. So that is alpha angle. Right. So then what are the forces? R2, and this R2 is on wedge y, no? That is perpendicular to this surface. So we don't need to worry about that. This surface is alpha angle, no? So this one is perpendicular to that one. So we don't need to worry about R2. Then M2G, what is the component? M2G sine alpha. So that is in the direction we are going. So M2G sine alpha. Then what else is in this system? R3 we don't need to consider because this R3 and this R3 cancel. Then only other force is mg, that is also vertical, no? So then that has the same angle, mg sine alpha in this direction, mg sine alpha plus mg sine alpha, because we are trying to find the component of mg along this surface. Okay, remember, along AC surface. So that is going to be mg sine alpha, right, times, sorry, equal. Now we need to figure out the accelerations for m2. M2 is the wedge y, so fp is in that direction. So simple fp. What about the other one, capital F? Capital F is not in that direction, so capital F, you can move it to here. Then capital F's component in that direction, that is going to be in negative. So negative F cos alpha, right? So that one is done. Then plus the particle has three components now, so we have to look at them. So let me mark all of them together. F, then the big angle is alpha, no? So that is Fy, and the small angle is alpha minus beta, and this big angle is alpha. This is Fp, right? So then this angle is what? The angle Fp makes with Fy. Big angle is alpha, small angle is alpha minus beta, so then this angle has to be beta, right? Okay, now we can figure out the acceleration in this direction, Fy direction. This is Fy, no, not Fp, right? So then we have to correct here also. This is Fy, right? So we have what? Fy is in that direction. We want the acceleration of this particle m in that direction. So Fy is positive in that direction. Then Fp component in Fy direction is what? Fp, move it to this side. So Fp cos beta. That is also in correct direction, so positive. Then how about F? This capital F acceleration is in negative direction, then F cos alpha, negative, minus F cos alpha, right? So this is equation 2. We need one more equation, so that is going to be using particle P only. So particle P is going in which direction? That direction. So we will apply F equals ma to that direction, alpha minus beta angle direction, right? So then what are the forces? Only forces acting on particle P are R3. R3 is what? R3 is perpendicular to that surface, so we don't need to consider that. Only thing we need to consider is mg component. So this angle is what? This angle is alpha minus beta. So then we know we want the component of mg along this surface. So that is going to be what? Mg sine alpha minus beta. Mg sine alpha minus beta. So mg sine alpha minus beta. That is the only force. So then apply the acceleration correctly. Then we have enough equations. So then m times, look at the acceleration. So we have to look at this one. So we are going in Fp direction, okay? This one, the middle one. So it's going to be Fp positive, and then Fy component in this direction, in Fp direction. So Fy cos beta, that is also going in positive direction. So Fy cos beta, and then F's component in Fp direction, that is going to be negative because it's going in that direction. F cos alpha minus beta. So minus F cos alpha minus beta, right? So here we have enough equations to find the acceleration of the wedge x, because we had three unknowns. Now we created three equations, right? So that is how you do part A of question number 12. Next, we will look at part B of this question.